So after seeing the simulation of an a bit stuffing, next the same program, a part B in that we last session we have seen about how the bit stuffing works and how to write a program for that, and we have also seen the how to execute that, how the execution of an bit stuffing is done. Next comes with an followed by a character oriented protocol, so which is called as a character stuffing. So before going to character stuffing, we need to understand what is the difference between the character stuffing and a bit stuffing. So name itself says a bit and a character. Bit is nothing but it's a binary digits which is often zeros and ones. So in a bit stuffing, whenever I found an consecutive ones in my data, I need to add an extra zeros. In a similar manner, a character is nothing but a bytes of a data, that is 8 bit is equal to a 1 byte. Here after an 8 bit, here I am going to use an a alphabets. So here I can say that if I found any letters which is continuous, I need to add in one extra character, that means nothing but a 1 byte. So why we need to add this character stuffing? So most of the time I can't use always the system cannot be always do the bit stuffing itself. Sometime it can be also operated the a character data also. So to know the character data, to differentiate from the beginning end of the frame and the starting end of the frame, sometimes I need to use a character to represent my data or the data what I have been received from an upper layer. So to do that, I use a protocol called as a character oriented protocol. So what is the use of this? To separate one frame from the next frame, that is a 8 bit of a flag is added at the beginning and the end of the frame. The flag composed of a protocol dependent, which are called as a special characters, signals that starts or end of the frame. So character stuffing. So what is that character oriented? So here the same thing what we have seen in a bit stuffing will have a same field, that is the flag, header, data field, Tyler, and again it has been added with the flag. So the data which has been already we have discussed in a bit stuffing, that is the data which has received from upper layer is nothing but a network layer. So we'll see the how the byte stuffing or a character oriented stuffing is done. So byte stuffing is the process of adding one extra byte whenever there is a flag or a escape character in that text. Flag and escape character, that nothing but the starting delimiter and an ending delimiter. For an example, if I taken a data called ATME, so I say that to differentiate a ATME College of Engineering, here the ATME has to be a one frame, college has to be another frame, off has to be another frame, engineering has to be another frame. Now I need to say to my system that these are the separate frames. So how the systems will make out these are my separate frames? So for that, what I need to do, I need to add something to understand the system, is it? So for an example, if I take a flag, these flags are nothing but it differentiate from a one frame to another frame. That means I have taken a flag called as an X for an source side and the flag as an Y at the destination side. That means a source or a starting delimiter as an X and ending delimiter as an Y. So whenever I found ATME College of Engineering, if I found ATME as a one frame and another ATME as an another frame, in this particular frame if I take ATME which are in consecutive characters or in consecutive frames, but I need to differentiate these first ATME with then second ATME, I need to put some special characters. Those special character is nothing but it is just to indicate the separation of this ATME is a one frame and another ATME is an another frame. So adding those the things to be an adding those things are what we call as a byte stuffing. That means I can add in a flag or I can add in a escape character in my text just to differentiate the things. So in a program we will come to know what how we are going to differentiate or how we are going to add an extra character. Fine. Next comes with a follows with a algorithm. First I need to read the character from the user and I need to measure the length of the character that has been entered from the user. Next I need to read the source delimiter from the character character from the user, and also I need to read the destination delimiter character from the user, and it will check each and every character with the source and the destination delimiter of a given pattern. If the character in the sequence is equal to the delimiter character, attach the same character immediately after the character, and the it process goes on repeat till the sequence gets completed. Once the sequence get completed, I can get the final output which will be displayed on my monitor. Next we'll look over inside how the character stuffing is done. So this is the program of a character stuffing. Here once again I am going to use a character. Obvious, I need to use a string.h file, which is includes then a character functions in a file, a header file. That is, those functions are string concatenation, string length. Those are the characters which are predefined in an string.h itself. And next comes with an standard input and output header files. So in this standard input and outer file, input and output header file will have a functions of an printf and an scanf. Next comes with the main program. I am going to consider a characters which are an and some of the characters as an intermediate signal. First I need to write an character with an called as an a, where I need to enter the characters to be stuff, which will be stored in an a with the array size of 30. And once again I have got an AFS, the frame size of an array size 50 with the empty size, and T of 3, that is an array of 3, and source delimiter, end delimiter, and intermediate signals. X is indicated as an input array, and Y is decided or indicated as an output array with an S array and an D array. Next, first thing I need to write the characters that is to be stuff. For an example, if I say the character is ATMECE, so when I found my ATMECE, it is the case one, which is a simple one. So this is my character ATMECE. So I need to say that which is the delimiter I'm going to, that is the to differentiate the this frame from another frame that is going to be arrived. So to do that, I have gotten a starting delimiter which has been considered as an A, and an ending delimiter with considered as an Z. So at the frame what I am going to be received, it will be have information of A, ATME, ECE, Z. This A and Z will indicate the this is ATME, CE is a single frame. So to do that, I need to write a program. We'll come back to the program once again. So write a character to be stuff, and those characters has to be stored in a variable called A, and again I need to enter what is the starting delimiter, and those values will be entered in a that is stored in an character called starting delimiter SD, and again I need to enter what is the ending delimiter. So far we have been seen here, that is the starting delimiter is A and ending delimiter is Z. So those values has to be stored, so that is going to taken in an ending delimiter as a variable called ED. So that will be stores the ending delimiter value, and next the function starts. So as I said that X is an input and Y is an output. First I need to take a starting delimiter. X of 0 is equal to S of 0 is equal to S of 1 is equal to that, but the finally the X of 0, the input will be an starting delimiter, that is starting delimiter is equal to A. So the next X is of an array of 3. I have taken only a single array. So you can also modify the program. So directly you can take a variable called as an character called as an X, and I can directly load the values to the X is equal to SD, just to make the understand of how the arrays work. We have considered an array. That's it. So here f of X of 1 and S of 0 2 is equals to a null, and again the delimiter has to be ending delimiter is stored in a variable called as an Y. So next, after initializing all these values, the concatenation has to be checked. So what I need to concatenate? I need to concatenate right now the X is equal to an A and Fs is an empty. So when I concatenate this Fs comma X, X is of a starting delimiter. Starting delimiter is nothing but it's an A. A gets concatenated then Fs, and finally the Fs will be an J. That means the flag of a flag field is ready. Next comes with a data what have been entered, that is the character. So once I need to read the character, what is the length of the character I have been taken, and after taking a length of the character I need to consider the array of an T. So whereas the array of the t is nothing but a of I, here the I is equal to 0, that is an ATME. I'm going to consider the first letter A gets stored with an a of t, and finally the t is equal to a. Next I am going to check whether t of 0 is equal to the SD. Right now the SD value is what? A, and t of 0 is equal to a. If those values are equal, then it's get concatenated with the S value. If not, it will check for whether ed is equal to t of 0. If doesn't get equal, this loop doesn't goes that is, this loop is doesn't going to be executed, and directly it's get concatenated. So if the loop gets and failed, that means the source delimiter is not equal to a value what have been taken, then it will check for the ending delimiter. So if the ending delimiter matches, it adds the fs with the ending delimiter character. Suppose if both values doesn't matches, that means the both case if statements gets failed, next it adds with an y, and the finally the output will be stored in an after stuffing called as an fs. So we look to then a cases. I've considered a 3 cases to make you better understand of the how the character stuffing is done. So first case already have been explained. We'll go for a second case. In a second case, what I have been taken, I'm going to take an A B C D E F. This is my characters. So this characters represents the starting delimiter. As I said that I'm going to consider X as my starting delimiter and then D as my ending delimiter. So when I go on processing that, first thing what I need to do, I need to take the X as a value, and I need to concatenate the fs with the empty cell, and I obtain an X value. Similarly, next I need to take an A value, and I need to concatenate, and I obtain an XA. Next I will do then XAB, and next XAC, and XABCD. So when I do this, so this bit gets incremented, this and ed is both are equal. Once this both are equal, then I'm going to add an extra character of an extra character of an ending delimiter D, and goes on it in E and F. So the final bit has been over. After doing that, again I need to add an ending delimiter which is added within D. So when I go for an case 3, so in an case 3, what are the things have been done? I have taken the character with the similar characters itself, A. So here each and every time the source and the destination both have been considered as in the same. So here what I need to do, I need to first take a starting delimiter. It has to concatenate with the starting data of a bit of an starting data, that is A. And again when I check for this A and this A, here we have got an A and again we have got an A, so both A are in common, I add the A. Similarly again A, again A, finally it will check for whether any other A is available. There is no other variable, so after no other variable available, finally the ending delimiter is going to be added. Thank you. So this is the simple program. So let me now look over to the how the character stuff simulation is done and how the execution will be carried out. So this will finish off the sections of an bit stuffing and then a character stuffing, and I looking forward for an for you to give a likes for the video if you like the stuff that have been explained, and also I request you guys to get subscribed to our channel Atmiya Electrons. Electrocrats. And if you have any doubts regarding to this particular stuffing or the program executions of a program, you can contact us with an to an email ID, or you can reach our to us by an email. You can ping the mail atmiyaelectrons@gmail.com. Once again I am going to repeat, you can reach us by an mail ID called atmiyaelectrons@gmail.com. and next we'll go to a next program. We're looking forward to release the next program to be carried out. Hi, hello, welcome back. So in the last session we have seen about then stuff that of the character stuffing. Today I'm going this section will be on the simulation execution, how the character stuffing is executed. So as I explained in a program, so I need to enter the characters to be stuffed, and also I need to enter the which is the starting delimiter and which is the ending delimiter. Once it has been done, I need to initialize as a starting delimiter into input and ending delimiter as an output variables, and I need to concatenate the things. If the things is okay, that if the A is the starting delimiter repeats once agagen, it has to append it with the one more time, and similarly the ending delimiter variables appears in a characters, again it has to be appended. If not, the finally the result will be appended with the appending a starting delimiter and a ending delimiter along with a character. So already though in a previous section, so what we need to do means I need to right click on this, open up empty new document, create a document, save it as an char.c, because we are writing a program in a C programming, so we need to save the extension in a .c itself. So I already have a program which has already written, so close that and once again open the terminal. So when we open the terminal, right now we are in an virtual box. Please get navigated into a cd by typing in a cd desktop. So it is a case sensitive, be careful with that. D, if you are going to write a D capital means you need to write a capital, you need to type a capital itself, or if you are going to use an a small means you need to use the small letter, because it is case sensitive, be careful with that. So cd desktop, so say enter, so it will navigate into a desktop. In a desktop, if you say ls, that shows the whatever the contents that is available in a desktop. So in a desktop I have gotten a file called as a char.c. You can find that here, char.c. I need to run this. So before doing the run, I need to compile the gcc. So gcc space char.c. so directly in the last section I have said I can use an output, so I will show those in this section, that is by executing in two sentence, I can write the same execution by using a single instruction, that is gcc filename.c -o space char, that is the file name. So when I say this, directly if you have any errors it will show an errors, if not it will show the warnings. So what I need to do, the main what I am going to use is an wimplete. This is an is warning, just it's not an error, you can edit it and else you can also clear it. So where I can see that whether it's an error or a not. So if you get an error, the same thing, go to your file. So how to clear an error, next is, so go to file. So here already in a desktop I have gotten a file called, so I will navigate into a desktop. In a desktop I have gotten a char folder. So here what it is asking, whether the main is an integer or not what. So avoid that, what I will specify it's an int. And once if I will need to save the file, whatever when you going to edit the gedit file, please save those things, then only this system is going to be done. So once it has been done, once again you go back, once again go to a terminal and run the instruction, that is gcc char.o char. So it will show an execution, so completion is done. So after that, step by step if you go with that, means gcc space char dot c. So compilation is done, that is it has been converted to a machine level language. And to run that we have gotten command, that is ./a.out. Why it is an a? Because it is a default which has been taken directly from the scratch of the gcc. So say enter. So now your program is going to be asked, enter the characters to be stuff. So I will write ATMECE. So if I write this, so if you say which is the character you need to be as an starting delimiter, I will say as an P, and I will save a one more which is the ending delimiter as an Q. So the final output should be an what? PATMECEQ. So the output is PATMECEQ. So we'll look over one more example, that is an ATMECE. So I've got an E here, two variables. So when I run, I will give an example. So what I need to be done, I will say is an dollar include as a dollar. And what is the ending delimiter? I will say it is an E, capital E. So what will be the stuffing? So you can look over here. Why it has been added twice? So this is the ending delimiter, that is E. This is the ending delimiter, and ending delimiter is E. So that is this one. So here is an E which is differentiate. That means now we can easily differentiate whenever if I send any data, wherever I found the character has been stuff, I can take into consideration that these are the different frames which has been differentiated by the stuffing process. So if I remove this by using an unstuffing, the final output is going to be, that is final, whatever the data that has been transmitted, that will be an cleared. That means whatever the data it has been transmitted, it will give the same original messages on messages. So thank you for the watching the character stuffing video. If you have any doubts, please reach us by an Gmail ID atmiaelectrons@gmail.com. And if you like these videos, please do like the videos and comment on the things that will make us to improve our explanations. And also please get subscribed by clicking on the subscribe button to our channel, that is Atma Electrocrats, and also click on the bell icon to get the more notification from our channel. Thank you.